Ever wondered why time passes more slowly for moving objects? This isn't science fiction, but a concept rooted in Einstein's theory of relativity known as time dilation. It's a mind-bending reality that the ticking seconds on a moving clock, say on an airplane, tick away more leisurely than those on a stationary clock, say on the tarmac. This isn't merely theoretical, friends. It's an observable and measurable phenomenon confirmed by precise experiments and even experienced by frequent flyers, like our stockbroker we'll hear from later. One such experiment involved 2 atomic clocks, the epitome of precision, and a speedy Russian Mark fighter plane. The result? Well, we'll get to that soon. So buckle up as we embark on a journey where time stretches and bends, where the common understanding of seconds, minutes and hours gets a little warped. Now let's delve into a fascinating experiment that demonstrates this concept in a tangible way. Scene script. Imagine 2 precise atomic clocks. One stays on the ground, the other takes a ride in a Russian Mark fighter plane, traveling at several times the speed of sound. Now let's dive deeper into this experiment. The atomic clock on the ground and the one in the plane were synchronized before the flight. The plane then took off and soared through the sky, pushing its Mach speed to the limit. Racing against time, it returned to the landing strip before running out of fuel. Upon landing, a peculiar thing happened. The 2 clocks, which were initially synchronized, showed different times. The clock that took the flight was lagging behind its grounded counterpart. Even though it was just a fraction of a second, this difference was significant. This experiment wasn't just about testing the accuracy of atomic clocks or the performance of a fighter plane. It was a test of Albert Einstein's theory of relativity. According to this theory, the faster an object moves, the slower time passes for it. This is known as time dilation. The difference in the time readings of the 2 clocks confirmed this fascinating aspect of the theory. The clock on the plane, which was moving at a high speed, experienced time dilation, causing it to lag behind the stationary clock on the ground. This experiment was a monumental step in our understanding of time and space. It challenged our common-sense view of time as a constant, unchanging entity. It revealed that time is, in fact, relative and can be influenced by speed and gravity. As unbelievable as it may seem, this experiment shows us that time does indeed slow down for moving objects. It tells us that if you were on that plane, racing at several times the speed of sound, you'd have experienced time passing slightly slower than the rest of us on the ground. It's a strange and mind-boggling concept, isn't it? But that's the beauty of science. It constantly pushes the boundaries of our understanding, offering new perspectives on the world we live in. And who knows what other exciting discoveries await us in our quest to understand the mysteries of the universe. Now, consider a stockbroker who flies between Chicago and Vancouver 3 times a week. He notices that his wristwatch lags by about a minute every 3 months. This isn't just any timepiece. It's one of the most accurate watches on the market, yet it consistently falls behind. Puzzled and slightly irritated, he decides to bring up the issue with the watch representative. He explains his predicament, but the representative is dismissive, asserting that such a thing is impossible. After all, these watches are renowned for their precision. Undeterred, the stockbroker insists on his observation. He explains that this is not an isolated incident. It happens regularly with both of his watches. One of these watches is set to Canadian time, the other to American time, and he switches them around with each trip. It's at this point that the agency manager steps in. With a bemused smile, he suggests that the stockbroker might be experiencing time dilation. The broker is taken aback. Time dilation? That's stuff of science fiction, surely, but it's not as far-fetched as it might seem. Remember, Einstein's theory of relativity tells us that time passes more slowly for moving objects. And what's always moving? The stockbroker, who's frequently on planes darting between Chicago and Vancouver, and his watches, always with him, are also subject to this phenomenon. The broker leaves the meeting with a newfound understanding of time dilation. It's not just a theoretical concept confined to physics textbooks. It's a real, tangible phenomenon that's subtly yet profoundly affecting his everyday life. So next time your watch seems to be running a tad slow, perhaps you're not just imagining things. Maybe you, like our stockbroker, are experiencing the fascinating effects of time dilation. It's a complex concept, yes, but it's also a captivating reminder of how time and movement are inextricably linked in our universe. Even in our day-to-day lives, we can see the subtle yet profound effects of time dilation. Now let's take things up a notch. What would happen if we could travel faster than the speed of light? Let's venture into the realm of the hypothetical. The theory of relativity does indeed tell us that as we approach the speed of light, time slows down. But what if we could somehow surpass that limit? What if we could travel faster than light itself? The consequences of such an achievement are mind-boggling. Picture this. An astronaut embarks on an interstellar mission equipped with the most advanced warp drive technology. This journey is set to last 10 years, but when our brave explorer returns to Earth, he finds himself not on the bustling landing strip he left behind, but in a barren desert. But it's not just the locale that's off. The time is wrong too. He hasn't merely travelled through space, he's travelled through time. He's gone back 60 years. One can only imagine the shock, the confusion, the disorientation. And what if this isn't just a thought experiment? What if these instances of time travel have already occurred, albeit accidentally? Could some of the unexplained phenomena we encounter today be the result of our own future missteps? Consider the many reported sightings of unidentified flying objects, the stories of alien encounters. Could these be not visitors from other worlds, but visitors from our own future? Perhaps the Roswell incident of 1947 wasn't the crash of an extraterrestrial spacecraft. Perhaps that pilot was one of our own, a child of our future, lost in the annals of our past due to a miscalculation in warp speed travel. These are, of course, mere speculations, but they serve to highlight the profound and baffling implications of faster-than-light travel. It's a tantalizing prospect, one that invites both excitement and caution. Could our UFO sightings and reported alien encounters actually be glimpses of our own future, distorted by the effects of time dilation? Only time, ironically, will tell.
Subscribe to the channel for more video, and please give us a thumbs up if you enjoyed this.